there's a new term. It's called Phygital.
That's right.
Maybe you can help us a little. What is it and what are the advantages of it?
Yeah, happy to do so. Thank you for the question. So Phygital, obviously, it's a combination where it's a blend of two words. So it's a blend of physical and digital. So we're looking at it in three dimensions. First of all, of course, the product, the Phygital product, which will always be a combination of something physical, and if it's only a hull for software, and the software part, the digital part. So the product is of course there. Of more importance to us is actually the Phygital process of how to develop products. And that could be a Phygital product or just a simple physical product like a hammer. What we think is important is to use software and to use the virtual space that we can create with software as long as possible to avoid to really make the physical part. By that we don't mean to delete prototypes completely and to avoid testing in the real world completely, but to take it to a level in the virtual world where we can trust it and then bring the full prototyping cycle to a different level. And the interesting thing there is that through all the development work that's been done in the past in the physical space, there's so much data and so much experience available that if we transfer this properly into the simulations, then we can really achieve a different level. And especially the German industry, which is very tedious in all its testing, we see a great chance to do so. But it is, in fact, a data gathering and a data conversion task. So all the experience that is out there has to be transferred into a database that can be then fed into the simulation. So that is actually the important task that we have to do, because if we don't do so, then it's just a theoretical examination of a CAD file where we have some very, very basic data properties as fed in. But those are idealistic data that has been from tensile strength tests or thermal tests. It's just theory. And that's the reason why we build prototypes, because we know in theory it should work. And now we do the testing in real world and we see, oh, it doesn't work, because in a manufacturing process, if we bend something, or if we do machining, then we have corners and it starts to break through thermal expansion, and then shrinkage again in casting processes or injection molding. We always have variations, let's put it. Let's not say there's no failures really. It's just the way that things behave when you heat them up and cool them down and machine them. But since this information is available, the experience is there. And if we manage to get this into the simulations, then we can arrive at a much, much higher level with the data and really avoid regaining experience that is already there. And the third dimension is how to combine products, whether that's phygital or just a purely physical product, into a network, which would be the Internet of Things. There also the term phygital has already been used, and for us also it has a lot of relevance because we're coming from the e-commerce space where everything is connected, and using the Internet of Things, or as we use it in Germany quite frequently, Industry 4.0. So what we're trying to do is that we synchronize the development processes of the software part, of the digital part, and the physical part, because the processes on software are just much faster, and they've arrived at a much, much higher level than the physical part. It's just that prototyping is so much easier with software than it is with physical parts. You have to construct them, and then you have to build them, and then you have to test them. And all that is done in the software world as well, of course, but it's much faster. Now, you might say that, hey, all of that is already out there. Yes and no, because of course, if you construct a part in a CAD file, you have a digital representation of it, and you can do a lot of things with it. You can simulate it, you can simulate the function, you can display it to customers, but it is just theory. And what prototyping does is transferring that theory into practice and in capturing experience, see where it fails, and trying to improve on it. And the important thing that has to be achieved here is that you take all the experience that you have from previous projects and feed that into the simulation. So it has to be a multi-step simulation where the manufacturing processes are being considered also as an input. And if you do so, then you have the chance to really arrive at a prototype level, a virtual prototype level, which is so close to reality that you can really rely on it. And we see basically two areas or two different directions to apply this to business. The first direction, which is probably a bit easier to approach, is looking at e-commerce. So e-commerce has already arrived at a very, very high level. It's pretty advanced. The achievements through the past 20 years has been just dramatic. And the pace is going on still, of course. And the task for many e-marketers these days is not to lose ground on the marketplaces. So big marketplace companies, we all know the names, are gaining so much control over the supply base and are also starting to, and that's the important term to mention here, the verticalization. So they gain control over the supply base and they start to build their own brands and start to develop their own suppliers. That means for marketers on a smaller scale, it's getting much more difficult to find suppliers that are willing to work with them. And it is also more difficult really to earn money because the pressure from the big marketplaces on the cost side is just immense, and that's really difficult for smaller marketers. And the only chance they have is basically to do the same thing and start to verticalize. So they have to get into the supply base, get control over what they do, come up with own product ideas and develop them, test them as early as possible to avoid expensive prototyping phases, which you simply cannot do because we're not talking about a single car here. In consumer electronics, fashion, we're talking about typically quite broad product ranges. And if you try to develop parts and produce parts for every single bit of your product width, then it's going to take too long and it's going to be too expensive. So the tool for that would be Phygital development, Phygital Product Development, trying to keep it as long as possible in the virtual space and present it to customers, get a qualitative feedback from the customers, incorporate that into the improvement, into the iteration cycle to improve the product. And then in the end, when you think you're at 95%, then you can go on and really make parts and then present it to the customer and do the testing really in the shops. And that leads us to the second direction. We would talk to industry customers that typically would use software to improve their manufacturing processes, probably also their R&D work to a certain extent. But they would probably not go as far as a business-to-business customer, as a business-to-business company, to think about own product ideas that they can sell to end consumers. Then you can take the risk and talk to end customers even, because you can do this at fairly low cost. It's not that you have to really build it and put it to a store and build thousands of it and see if somebody buys it. You can develop it to the very end and do the customer testing with your own. So if it was an end customer, it's a consumer testing with it. And suddenly, industry customers who never thought about doing end consumer business have a chance to do that and to develop their own business models, end consumer business models. And of course, in the first place, we're looking at it as a means to help companies to grow and move into other business fields. But we're also looking at it as from a much higher perspective, because we are convinced that there are so many tasks out there, technical tasks that we have to complete, just in the area of energy sustainability, where we have to really speed up the development processes to gain higher outputs from windmills, solar, H2, hydrogen. There's so many tasks that we have to do which are expensive, of course, because building a high pressure tank for a hydrogen tank is something. Building a pipeline, there's pipelines already in Germany. There's like 150 kilometers of pipeline in the Ruhr area for the chemical industry. But expanding this into a much broader space and to higher pressures probably will take a lot of development work. And if we rely on the classical way of doing it, building prototypes and testing it, it first of all takes too long. And with all the work that we have to do, it will also be simply too expensive. So with the experience and with the simulation tools that are out there, and with the process ideas coming from the software world of how to do this in an agile way, so faster iterations, working more in parallel, we think that we can really be much faster and achieve a higher level of innovation in a shorter time. So looking at it from a broader perspective, it's not just like a marketing activity where we're trying to consult certain companies to push product faster into the market. We think that there really is a higher need out there that companies have to meet, and we think the tools are there. They just have to be developed and applied in a better way than we do it today. And with that, it should be very interesting and fascinating projects.